Hello friends, now in this video we will learn the Pythagoras theorem for the acute angle triangle, Pythagoras theorem for the obtuse angle triangle, and then we will derive the relation, that is we will derive the formula for the Apollonius theorem. Now let us start. In this video I had explained all the examples in a very simple language, and you will understand all the problems whatever that I had explained. Now let us start. In a triangle, relation between the sides opposite to acute angle and the remaining sides, and relation between the sides opposite to obtuse angle with the remaining two sides. Very interesting, this formula, and we will derive by using the Pythagoras theorem. Can be determined with the help of Pythagoras theorem. Now let us start. The first, in triangle ABC, angle C is an acute angle. Segment AD is a perpendicular to segment BC. Then prove that AB square is equals to BC square plus AC square minus 2BC into DC. This is we want to prove. Now see this here. This is the triangle ABC. AD is the perpendicular to BC. Again see this here. Now see this here first of all. The triangle ABC, where the angle C is the acute angle triangles, and I had shown this, that is a side AC is opposite to angle B, therefore it is a small b. Side AB is opposite to angle C, therefore it is a small c. And the side BC is opposite to angle A, and therefore whole is treated as A, and this distance, that is a DC, is x. Therefore BD is equals to A minus x. Now see this here. In given figure, let AB is equals to C, AC is equals to B, AD is equals to P, the length. That is, AD is a perpendicular to BC, and we treat it as P, small p. BC is equals to A, DC is equals to x, BD is equals to A minus x. And now see this, in triangle ADB, which is the triangle ADB. By Pythagoras theorem, what will happen here? That is, AB is the hypotenuse, and these are the two remaining sides. Now see this here. And again, one thing is that we want to prove that AB square, and that's why we are taking here, this is the AB square. Which is equals to C square. Now see this here. In triangle ADB, AB square is equals to AD square plus BD square. Now here AB square is equals to AD square plus BD square. The value of AB is C, therefore it is a C square. The value of BD is A minus x bracket square. And the value of AD is a P square. Now see this again here. Now here a minus x bracket square. Therefore a square minus 2ax plus x square plus b square. This is given in the textbook in the form of the activity. This is equation number 1. Now again in triangle ADC by Pythagoras theorem. Now see this triangle ADC. AC square is equals to AD square plus DC square. That is a B square is equals to B square plus X square. Now one thing is that whatever that we want to prove, that is AB square is equals to BC square plus AC square minus 2BC into DC. That is, in this proof there is not a mention of AD, and that's why we will try to eliminate that. Now see this again here. AC square is equals to AD square plus DC square. B square plus X square. Now here we will find out the value of P square. This is the value of P square. And we will substitute here. The P square is equals to B square minus X square. And there the plus X square and minus X square will get cancelled. Now see this here. Put the value of P square in here. The value of P square is here, where C square is equals to A square minus 2x plus X square plus B square minus X square. Now here plus X square and minus X square get cancelled, and you will get, that is a square plus X square minus 2ax. And then we will substitute what is meant by A, what is meant by X, what is these names of this B. That is the meaning of the B. C square is equals to A square plus B square minus 2ax. Now what is meant by C square? It's clear that the small c is the side opposite to angle to the side AB. Therefore we treat as this is the AB square. And again small a square, which is opposite to angle A, and that is nothing but it is a BC. And the B means what are the remaining two terms? That is A and C, that is AC. Now the same thing is replaced by here. C square means what? AB square. This is the C square. A square means what? BC square. A square means what? BC square. And B square means what? AC square minus 2A. Again BC. And X means what? That is the DC. This is we want to prove. Again same thing. I am repeating from the board. Again same thing is here. In triangle ABC, angle C is an acute angle. Here is acute angle. Then prove that AB square is equals to BC square plus AD square minus 2BC into DC. That is, we want to prove that C square is equals to A square plus B square minus 2AX. Now in figure, that is AB is equals to, that is a side opposite to angle C is a small c, side opposite to angle B is a small b, and the side opposite to angle A is a small a. And also we treat here one more thing is that DC is equals to X, and therefore BD is equals to A minus X. It's very simple that in first triangle ADB we will apply the Pythagoras theorem. That's we want to find out AB square, and next we will apply the Pythagoras theorem for the ADC. Now see this, in the triangle ADB, this is ADB, by the Pythagoras theorem, C square, that is AB square, is equals to a minus x bracket square plus ad square means what? B square. Therefore, c square is equals to a square minus 2ax plus x square plus b square. This is the first part. Now also in triangle ADC. In this triangle, that is a b square is equals to p square plus x square. Now we will substitute here the value of this p square. I already say that in that is whatever that we want to prove, there is not a mention of this side AD, and that's why we will try to eliminate it. Therefore, p square is equals to b square minus x square. We'll substitute the value of p square here, then you will get c square is equals to a square minus 2ax plus x square plus b square minus x square. Therefore, c square, that is here, the plus x square and minus x square get cancelled, and then you will get c square is equals to a square plus b square minus 2ax. It's a clear that here is a small c square. It means that the opposite side, that's a side is ab square. Small a square means what? Which is the remaining two terms? That is a bc square. B square means what? What are the remaining? AC square. And we have considered x is DC. Again, this here is a small a, which is again the BC, and this is the first part that we have proved. In this case, we consider that the angle C is acute angle triangle. Now, next we'll see that when the angle is obtuse angle. Now the next is that is in triangle ABC, angle ACB is an obtuse angle. Segment AD is a perpendicular to segment BC. Then prove that, now see this the triangle. This is a perpendicular from the vertex A, where BC is produced up to the point. This is the figure. In triangle ABC, here angle C is obtuse angle. And again BC, that is a small a, AC is a small b, and perpendicular drawn we always treat as AD as a P and DC that is equals to X. Now see this, what we want to prove. Therefore, AB square is equals to BC square plus AC square plus 2 BC into CD. Okay. Now the next, we'll prove this. In triangle, that is in the given figure, that is segment AD is a perpendicular to segment BC produced. Let AD is equals to small p, AC is equals to small b, AB is equals to small c, and BC is equals to small a, and DC is equals to X. DB is equals to A plus X. Therefore, in triangle ADB, now first we'll consider the triangle ADB. What is here? AC square is equals to AD square plus DB square or BD square. Means what? C square is equals to P square plus in bracket A plus X bracket square. Now see this here. By Pythagoras Theorem, ADB, C square is equals to in bracket A plus X bracket square plus B square. Now we'll expand this, that is A plus X bracket square, A square plus 2AX plus X square plus B square. This is one. Now we will substitute the value of the phi. Similarly, in triangle ADC, ADC. Measure of angle ADC is a 90. That is a b square is equals to p square plus x square. B square is p square plus x square. Now we'll again here substitute the value of p square. The value of p square is equals to b square minus x square. This is number 2. Therefore, substituting the value of p square in equation number 1, therefore you will get c square is equals to a square plus 2ax plus x square plus b square. We have substituted the value and rearrangement of the terms. That is a p square means what? B square minus x square plus x square minus x square get cancelled, and you will get c square is equals to a square plus 2ax plus b square. Therefore, c square is equals to a square plus b square plus 2ax. Now we'll substitute the value. C square means what? AB square. Here is a first is AB square. A square means what? AC square. BC square, and B square means what? AC square plus 2a. Again, this is A means what? BC, and X means what? That is a DC. 2BC into DC or CD. Therefore, AB square plus BC is equals to AB square is equals to BC square plus AC square plus 2BC into CD. This is we want to prove. Now, again we will see from the board whatever that I had written. Now see this in triangle ABC, measure of angle ACB is the obtuse angle. Segment AD is a perpendicular to segment BC. Then prove that AB square is equals to BC square plus AC square plus 2 times BC into CD. Now in figure, AD is a perpendicular to BC. And here we consider that, let's suppose that AD is equals to small p. Again the same thing, AC is a small b, AB is a small c, BC is a small a, DC is a small x, DB is equals to a plus x. In triangle ADB by the Pythagoras theorem. What is in triangle ADB? ADB. AB is the hypotenuse whose length is c. Therefore, c square is equals to, again BD square means what? A plus x bracket square. AD square means what? P square. A plus x bracket square, that is a square plus 2ax plus x square plus p square. And here, see this again here. Similarly, in triangle ADC, now see this triangle ADC. Here b square is equals to p square plus x square. This is the value of b square. Now see this, b square is equals to x square plus p square. Therefore, p square is equals to b square minus x square. Substituting the value of p square from 2 in equation number 1. That is, here we will substitute the value of p square. What is the value of p square? Is a b square minus x square. Therefore, c square is equals to a square plus 2ax plus x square plus p square. The value of p square is a b square minus x square. Here plus x square minus x square get cancelled, and we get c square is equals to a square plus 2ax plus b square. And it is written as c square is equals to a square plus b square plus 2ax. Now here is a c square means what? AB square. A square means what? BC square. B square means what? AC square. That we have treated here, have considered here. Therefore, we have here, that is a AB square is equals to BC square plus AC square plus 2 times BC into CD. Now we will prove the Apollonius theorem by using 2. Now see this here. Apollonius Theorem. Now on this theorem, board always ask the examples and not to prove that. In triangle ABC, M is the midpoint of side BC. Then AB square is equals to AC square plus 2 times AM square plus 2 times BM square. That is a triangle ABC. M is the midpoint of side BC. That is the AM is the median of the triangle. See this triangle. Triangle. This is the triangle ABC. ABC. M is the midpoint of BC. AD is a perpendicular to BC. Therefore, AB square plus AC square is equals to 2 times AM square plus 2 times BM square. In triangle ABC, M is the midpoint of side BC. To prove that is to prove AB square plus AC square is equals to 2 times AM square plus 2 times BM square. Construction. That is a draw perpendicular AD, the segment BC. Proof. If AM is not perpendicular, that is AM median is not a perpendicular to BC, then out of AMB and AMC, AMB and AMC, one is obtuse, that is AMB is obtuse, and other is acute angle AMB. This is obtuse angle and AMC is the acute angle. The other is acute angle. Now in figure, AMB is obtuse angle and AMC is acute angle. Therefore, in triangle ABM, AB square is equals to AM square plus BM square plus 2 times BM into MD. This is the first part. That is, again we will see here. This is the figure and the triangle AMB. Now see this again here. AB square is equals to AMB triangle. We are considering the triangle AMB. AB square is equals to AM square plus BM square plus 2 times BM into MD. ABM. Now see this again here. That is a ABM. Now see this here. Again, in triangle AMC, this is the triangle AMC. The angle M is an acute angle. Therefore, that is M is acute angle. Therefore, AC square is equals to AM square plus MC square minus 2 MC into MD. Therefore, AC square is equals to, here again see, if we add these two equations, we are replacing here, that is BM is equals to MC and we substitute the value. Therefore, if we add these two equations, this is the equation number 1 and equation number 2, then you will get AB square plus AC square. What will happen? That here is a AM square, here is again AM square, that is a 2 times AM square. Next is a MB square and BM square and MB square, both one and the same, they will add each other and these two will get cancelled. This is the plus and this is the minus. Therefore, we will get AB square plus AC square is equals to 2 times AM square plus 2 times BM square. Now see this here. AB square plus AC square is equals to 2 times AM square plus 2 times MB square therefore AB square plus AC square is equals to 2 times AM square plus 2 times BM square. From this example, we can see the relation among the sides and the median of triangle, and this is known as Apollonius Theorem. Now again I will repeat this from the board, whatever that I had written. Apollonius Theorem in triangle ABC, M is the midpoint of side BC, then AB square plus AC square is equals to 2 times AM square plus 2 times BM square. Given in triangle ABC, M is the midpoint of side BC, then prove that AB square plus AC square is equals to 2 times AM square plus 2 times BM square. Draw the perpendicular segment AD on BC. AM is not perpendicular, that is, then we consider these are the two cases. Suppose this is not the perpendicular, then one of them is a acute and another will be the obtuse angle. Okay, therefore in figure A and B, what's happening in the figure A and B? This is the obtuse angle and this is the acute angle. Therefore, we'll apply the formula for the obtuse angle and the acute angle. Now, when this is the acute angle, then that is a AB square is equals to AM square plus BM square plus 2 times BM into MD. This is the first part. That is AB square is equals to AM square plus BM square plus 2 times, that is the BM into MD. Now for the triangle AMC, this is the acute angle. Therefore, AC square is equals to AM square plus MC square plus 2 times, here is a, minus 2 times MC into MD. This is the second part when the angle is a acute angle. Now we'll add these two. Again here, as M is a midpoint, therefore BM is equals to MC. We'll substitute the values and add these to equation number 1 and equation number 2. Here is a AB square, here is a AC square, AB square plus AC square, AM square, here is also AM square, both of them have AM square, that will become 2AM square, and these two terms will get cancelled, and hence we get AB square plus AC square is equals to 2 times AM square plus 2 times BM square. From this example, we can see that the relation among the sides and the median of a triangle. This is known as Apollonius Theorem. Now we'll see the practice set 2.2. The first question, in triangle PQR, point S is the midpoint of side QR PQ is equals to 11, PR is equals to 17, PS is equals to 13. Find QR. Now see this figure in triangle PQR. PS, that is PQ is equals to 11, PR is equals to 17, PS is equals to 13. We want to find out the QR. Now here, as S is the midpoint and we have given the two sides and the length of the median, we can find out the third side by using the Apollonius Theorem. Now see this here. In triangle PQR, PQ square plus PR square is equals to 2 times PS square plus 2 times PS is the median that we have to write here. Here is a 2 times QS square. I think that I forget to write here. 2 times QS square. Now I had changed it. No problem. Now see this here. Now in the triangle, this is a PQR. The PQ square plus PR square. 2 times PS square plus 2 times QS square. That is a length of PQ is a 11 square. Length of PR is a 17 square. Length of the PS is a 13. Therefore 2 times 13 square plus 2 times QS square. Now we'll substitute and calculate it. That is the square of 11 is 121 and the square of 17 is 289. 2 into 169. 2 times QS square. Therefore 410 is equals to. Now this is the calculation, that is a 2 times QS square is equals to 410 minus 338, and that's why you will get 2 times QS square is equals to 72. Therefore QS square is equals to 72 upon 2, that is equals to 36, and QS is equals to 6. And therefore QS is equals to 1 upon 2 QR. That is 6 is equals to 1 upon 2 QR, and therefore QR is equals to 2, that is equals to 12. This is the third side, as S is the midpoint of QR, therefore QR is equals to 12. And this is the answer. Now again I will show whatever that I had written on the board. Now see, this is the practice set 2.2 in triangle PQR. S is the midpoint of side QR. If PQ is equals to 11, PR is equals to 17, PS is equals to 13, find QR. This is given, that is a triangle PQR. PS is 11, PR is 17, PS is 13. We'll apply here that the PS, as the PS is the median, we'll apply Apollonius Theorem. That is 11 square plus 17 square, that is equals to 2 times 13 square plus 2 times QS square. That is 121 plus 289 is equals to 2 into 169 plus 2 into QS square. And that is the 410 is equals to 338 plus 2 times QS square. Therefore 2 times QS square is equals to 410 minus 338. Therefore 2 times QS square is equals to 72. Therefore QS square is equals to 72 upon 2, that is equals to 36. Therefore QS is equals to 6. Now this is the QS, but the QR is equals, that is the QS is equals to 1 upon 2 QR, and therefore we have written as S is the midpoint of QR. That is 6 is equals to 1 upon 2 QR. QR is equals to 6 into 2. QR is equals to 12, and this is the what we want to find out the value of the QR, that is equals to 12. Now next problem. In triangle ABC, AB is equals to 10, AC is equals to 7, BC is equals to 9. Then find length of median drawn from point C to side AB. that we want to find out the length of the median. This is the triangle ABC. Now from the point C we will draw here median. We have given that is a AB is 10, AC is equals to 7, BC is 9. We will draw the median from the point C. Now this is the median. Treat it as M is the midpoint. In triangle ABC, MC is the median. Therefore, AM is equals to 1 upon 2 AB, that is equals to 1 upon 2 into 10, that is equals to 5. Therefore, AM is equals to 5. Now, by Apollonius Theorem, AC square plus BC square is equals to 2 times MC square plus 2 times AM square. Here we are applying the formula for the Apollonius. Now here one thing is that the median is drawn from the point C on this side AB. Therefore, the formula is AB square, AC square plus BC square plus 2 times AM square plus 2 times MC square. Now this is the formula. We'll substitute the values. 7 square plus 9 square, that is a 2 times MC square plus 2 into 5 square. Now these are the values. 7 square is a 49, 9 square is 81, 2 MC square, 2 into 5 square, that is a 25, that will become 50. Now next is 49 plus 81, that is a 130, that is equals to 2 times MC square plus 50. 130 minus 50, that is equals to 2 times MC square, and their subtraction, which is 80 upon 2 MC, that is equals to MC square. Therefore, MC square, that is equals to 40. Now we'll take the square root on both sides. That is a root of 40. Now factorize this, that is a 4 into 10. The square root of 4 is a 2 root of 10. 2 root of 10. Therefore, MC is equals to 2 root of 10. Therefore, the length of the median drawn from the point C to the side AB is 2 root 10. Now we'll see this again, whatever that I have written on the board. In triangle ABC, AB is equals to 10, AC is equals to 7, BC is equals to 9. All the sides are given here. Then find the length of the median drawn from the point C to the side AB. In triangle ABC, MC is the median. AM is equals to 1 upon 2 AB, that is 1 upon 2 into 10, that is equals to 5. Now by the theorem, Apollonius Theorem, that is AC square plus BC square is equals to 2 times MC square plus 2 times AM square. Therefore, here we will substitute the values. That is a 7 square plus 9 square. That is a 2 times MC square plus 2 into the value of AM, that is 5. Therefore, 49 plus 81, that is equals to 2 times MC square, 2 into 25, that is a 50. And therefore, here see this, that 130 minus 50 is equals to 2 times MC square. Therefore, MC square is equals to 40. Therefore, MC is equals to root of 40. Now, 40 can be written as 4 into 10. That is a 2 root of 10. Therefore, MC is equals to 2 root of 10. Therefore, the length of the median from the point drawn from the point C to the side AB is 2 root 10. And this is the length of the median. Now, we'll see the next problem. Problem number 3. In figure, PS is the median of triangle PQR and PT is a perpendicular to QR. Then prove that. Now see this here in figure. PS is the median of the triangle PQR. Now here QS is equals to SR. and PT is a perpendicular to QR. Then we want to prove that. See this here first. PR square is equals to PS square plus QR into ST plus QR bracket square. And second is PQ square is equals to PS square minus QS into ST plus QR upon 2. Now the next is that is in triangle. Now in triangle PQR, S is the midpoint of QR. QS is equals to SR is equals to 1 upon 2 QR. Next is also in triangle PTS. Now this is a right angle triangle. Measure of angle is 90. Therefore by Pythagoras Theorem, PS square is equals to PT square plus TS square. These are the formulas that we will require when we will prove these two results. Now what is our first result? Our first result is PR square is equals to PS square plus 2 times QR into ST plus QR upon 2 bracket square. Now here we are considering the PR square. Now PR is the side opposite to obtuse angle. See this here. This is the PR which is opposite to this obtuse angle, and therefore this PR square is equals to PS square plus this QR upon 2 means what? This, that is a SR square means what? QR upon 2 bracket square, and again the addition of these two quantities. Now see this here. That is in triangle PTR. We first consider that is a right angle triangle. PR square is equals to PT square plus TR square. That is a PR square is equals to PT square plus. But what is a TR? If you see the figure, TR is equals to TS plus SR. You can see this figure here also. I will show you. TS plus SR. Now TR is TS plus SR. Now we'll expand this. That is the TS plus SR bracket square. Therefore, TS square plus 2 times TS into SR plus SR square. Now here we'll collect the terms. That is a PT square plus TS square. Here is a PT square plus TS square, and the value of PT square from the figure and the TS square, that is equals to PS square. You see this here. That is a PT square plus TS square, that is equals to PS square. See this here. And the next 2 times ST into SR plus SR square. Now this is the PS square plus 2 times ST into SR plus SR square. Therefore PS square plus 2 times ST. Now what is SR? SR is nothing but S is the midpoint of the QR. Therefore it is QR upon 2. And again here SR, which is a QS upon 2 bracket square. QS upon 2 bracket square. Therefore PS square plus St into QR, QR upon 2 bracket square. This is the PR square which we want to prove. This is the first part. Now again I will show you here. Now this is the first result, that is a PR square. Now this PR is a side opposite to this obtuse angle. Which is obtuse angle? That is a PSR. Therefore we'll first consider the right angle triangle PTR. In this right angle triangle, PR square is equals to PT square plus TR square. PR square is equals to PT square plus TR square. PT square plus TR square. But what is a TR? TR is a TS plus SR. See this here. TR is a TS plus SR. Expand this. PT square plus TS square plus 2 times TS into SR plus SR square. And therefore we'll collect these two terms. That is a PT square plus TS square. If you see this, PT square plus TS square, that is nothing but the PS square. Therefore we'll replace here PT square plus TS square by the PS square. And the remaining two as it is. That is a 2 times ST and SR plus SR square. Now what is SR? S is the midpoint of the QR. Therefore SR is equals to QR upon 2 because we required the result in the form of the QR. Therefore we are replacing the value of SR, that is equals to QR upon 2. Therefore we substitute the value of SR QR upon 2 plus QR upon 2 bracket square, and hence the result PR square is equals to PS square plus 2 plus QR into ST plus QR square QR upon 2 bracket square. Now we'll see the second result. Now for the second result, that is a PQ. See this here. That is a PQ square. PQ square is equals to PS square plus, he said that the QR square. If you see this figure, now see this again here figure. That is a, we want to prove that PQ square. PQ square is equals to again PS square plus QS square. Yes, we know that the QS is nothing but the QR upon 2. This is the first part. Now as angle is acute, minus 2 times that minus QR into ST. Now see this here. That is in triangle PTQ. Measure of angle PTQ is 90. PQ square is equals to PT square plus QT square. But what is the value of the QT? QT is QS minus TS bracket square. And we will expand it. That is, we are considering the triangle. This is the triangle, which is that PTQ. That is PQ square is equals to PT square plus QT square. But what is this QT? QT is in the form of the QS. That is QS minus TS bracket square. Therefore, see this here. QT is QS minus TS. Expand this. QS square minus 2 times QS into TS plus TS bracket square. Now the expansion of this, that is a PT square plus TS square, PT square plus TS square, that is nothing but the PS square. Now see this again here. PT square plus TS square, which is nothing but the PS square. Now the next is QS. QS means what? QR upon 2. Again there is a QS, which is a QR upon 2 into TS. Therefore PS square minus QR into TS plus QR upon 2 whole bracket square. And this is the second part and hence proof. Now again I will show here the second part. For that we consider the triangle PTQ. Therefore PQ square is equals to PT square plus QT square. See this here. The second part. PQ square, PT square plus QT square. The value of QT, as we have seen this here. The value of QT is nothing but a QS minus TS. Here is a QS minus TS bracket square. QS square minus 2 times QS into TS plus TS square. Therefore, PT square plus TS square plus QS square minus 2 times QS into TS. Again, the PT square plus TS square, that is the PS square. And the QS means what? QR upon 2 bracket square. Minus 2 times. Again, the QS means what? QR upon 2. These two to get cancelled. And we get the result PQ square is equals to PS square minus QR into TS plus QR upon 2 bracket square. Now the next is. Now the question number 4. In triangle ABC, point M is midpoint of side BC. If AB square plus AC square is equals to 290 centimeter square, AM is equals to 8 centimeter, find BC. This very simple problem. This is the triangle ABC. M is the midpoint. And here we will apply the Apollonius Theorem. That is AM square plus AB square plus AC square, that is equals to 2 times AM square plus 2 times BM square. See this here. By the Apollonius Theorem, AB square plus AC square is equals to 2 times AM square plus 2 times BM square. Here we will substitute the values. That is a 290 plus 2 times 8 square. They have given the value. Plus 2 times BM square. Simple calculation is there. That is a 290 is equals to 2 into 64 plus 2 times BM square. Therefore, 290 minus 128 is equals to 2 BM square. Therefore, 162 is equals to 2 BM square. Therefore, BM square is equals to 162 upon 2. That is equals to 81. Therefore, BM square is equals to 81 and BM is equals to 9. And the BM is equals to 1 upon 2 BC. Therefore, 9 is equals to 1 upon 2 BC. Therefore, BC is equals to 18 centimeter. This is what we want to find out. Again, we'll see from the board whatever that I had written. In triangle ABC, M is the midpoint of side BC. If AB square plus AC square is equals to 290 centimeter square, AM is equals to 8, find BC. Now in triangle ABC, here AM is the median by the Apollonius theorem. AB square plus AC square, that is equals to 2 times AM square plus 2 times BM square. That is equals to 290 is equals to 2 into 8 square plus 2 times BM square. 290 is equals to 2 into 64 plus 2 times BM square. That is a 290 minus 128, that is equals to 2 BM square. Therefore, 162 is equals to 2 BM square. Therefore, BM square is equals to 162 upon 2, that is equals to 81. Therefore, BM is equals to 9. Again, the BM is equals to 1 upon 2 BC. Therefore, BC is equals to 2 into 9, which is the 18 centimeter. This is the length of the third side. Now the next problem is problem number 5. In figure, TS is in the interior of a rectangle PQRS. TS square plus TQ square is equals to TP square plus TR square. Now see this. That is a rectangle. We join this, that is a PT, QT, TR, ST. Again, draw the AB parallel to PQ and SR. Now, in this case, this is very simple as PQ RS is the rectangle and PS is the parallel to the side SR. It's clear that it is a parallel to PQ. Now, these two sides are parallel and measure of this angle is 90. Therefore, measure of this angle is also 90. Therefore, we have that is a P, Q, B, A is a rectangle, A, B, R, S is also rectangle. What is the main thing is that here we will find out the value of TS square and the TQ square. To find out the TS square, we will apply here the triangle ATS. And the TQ square, we say that the triangle, we consider the triangle TQB. Now see this here. And again, next TP square. For the TP square, we'll consider the triangle PTA. And the TR square, we consider the triangle TRB. Now see this here. That we have segment AB is a parallel to segment SR and segment PQ is a perpendicular to segment PS. Segment PQ is also perpendicular to segment SR. Measure of angle is 90. Therefore, SR is also perpendicular to PS. SR is perpendicular to QR. AB is a parallel to side SR. AB is a perpendicular to PS. And AB is a perpendicular to QR. This is sufficient by the transitivity. Now, what we want to find out, we will find out the first of all TS square. That is, we will consider that is a triangle TAS. Measure of angle TAS is equals to 90. TS square is equals to 80 square plus AS square. This is the one. Next is TBQ. In triangle TBQ, measure of angle TBQ is 90. Again, you can see this from the figure. This is the TBQ. Therefore, TQ square is equals to QB square plus TB square. And what is here? ATS. That is a TS square is equals to AS square plus AT square. This is number 2. If we add these two equations, then we will get that is a TS square plus TQ square. That is equals to AT square plus TS, AS square plus BQ square plus QB square. This is the addition. Now the next is now in triangle TAP. Now we'll consider the right hand side. In triangle TAP, now see this figure, that is a TAP, that is equals to PT square. Now we'll find out the value of PT square and the TR square. For the PT square, we'll consider the triangle PAT, and for TR square, we'll consider the triangle TBR. Now see this here. TP square is equals to TA square plus AP square. This is the fourth one. TBR, that is the TR square is equals to TB square plus BR square. TB square plus BR square. This is the fifth one. Now TP square plus TR square is equals to TS square plus AP square plus TB square plus BR square. This is the number 6. Now on the both sides, that is there is a T is a common from the figure. ASRB is a rectangle. Now here, what are the same sides? That is here AT square, here is a TS square, both are same. The first is again TB square and TB square, here is a both are same. Now we want to find out the AS and the BQ. They are equals to AS is equals to BR. Also from the rectangle APQB, the rectangle, and therefore AP is equals to BQ. Now see this here. Here AT square is equals to TS square, and next is a TB square. Here is a TB square. Therefore from 3 and 6, the right hand sides are equal. Therefore TS square is equal plus TQ square is equals to TP square plus TR square, and hence the result is true. Result is true. Now see this again here. That is first in the triangle TAS. This is the triangle TAS. What we want to do? That is first we will find out the values of this left hand side, then right hand side, equate them. That is first the TAS. That is the TAS. TS square is equals to AT square plus AS square, and from the triangle, that is the TBQ. Here is a triangle TBQ. Therefore TQ square is equals to TB square plus QB square. TQ square, that is the TB square plus BQ square. Add these two. We have these two sides. That is the TS square plus TQ square is equals to AT square plus AS square plus BQ square plus TB square. Now again we will consider here the right hand side. That is the TP square and TR square. To find out TP square, we will consider the triangle. That is the PAT, and TR square, this is the TRB. Now the first is TAP, that is TS square plus AP square, and TBR, here is a TBR. TR square is equals to TB square plus BR square. Therefore we add these two here. That is adding these two, we get TP square plus TR square, TA square plus AP square plus TB square plus BR square. Now this is the equation number 6, and here is equation number 3. All these sides are of the right hand sides are equal, and that's APQB is a rectangle. AP is equals to BQ, and therefore from 3 and 6, TS square is plus TQ square is equals to TP square plus TR square, and therefore that is the result is proved. And that is in this way we have completed the practice set 2.2. I hope that you have understood all the problems whatever that I had explained. Now we will see in the next video. Till then, goodbye.